Hi friends, I'm Veera Ravi. I'm back with an interesting content for you guys. That is Hadoop interview questions. The Hadoop interview questions I have categorized four categories, not three categories. Initially I thought for three categories, but I decided to keep it in four categories. The categories are like the categories are like L1 category, very basic level, L2 category, L3 category, and L4 category. So L1 is a very basic here, and L4 is some expertise level. Okay, so here what I'm going to do as part of this playlist, so I'm going to upload every day topic wise some interview questions. I know that most of the guys are asking me, they understand the concept, they did the hands-on, they did the practical, but because of this new technology, so because they are not really worked on this, when they go for interview, due to the fear, they're not able to answer the questions properly. Okay, so to make them uh, enable, or I can say to make them to answer questions properly, I started preparing the interview questions here. I started preparing interview questions here. Okay, so let's see what. So I started with the Hadoop. So very basic questions: what is Hadoop, what is big data, kind of questions. Then I'll be keep moving to topic wise like HDFS. I'll be putting you giving you more than 50 to 60 questions over there, and I'll be giving you MapReduce. I'll be giving you another 50 to 60 questions on Hive, Pig, HBase, and so on. Okay, so let's start today's with the Hadoop interview questions. Let's start with the Hadoop interview questions. So the first one, what is Hadoop? It's a very frequent question, guys. As soon as you get into the interview room, the very first question they will ask you, what is Hadoop? The very first question is, what is Hadoop? So it's a very simple answer for that. The answer is Hadoop is a open source Java based framework. What is Hadoop? Hadoop is Java based open source framework which will store huge amount of the data, and it will process the huge data efficiently. So how it will process, how it will store? So for that, Hadoop come up with two beautiful components. Hadoop come up with two beautiful components. What are those components? The components are, one is HDFS, other one is MapReduce. What is HDFS? What is MapReduce? So here, as I said, Hadoop is a open source Java based framework which will store huge data and which will process the huge data. Correct? So here there are two tasks. One is storing the data, another one is processing the data efficiently. Everyone can, even existing system also can store the data, existing system also can process the data, but how it is different from there, we will see as part of the other interview question. So here the first task is storing. Your HDFS says that how to store the data, and your MapReduce says that how to process the data efficiently. So the first question, the the answer for the first question is, what is Hadoop? Hadoop is a open source Java based framework which will store huge amount of the data and process the huge amount of the data efficiently. So how it will store, how it will process? For that, Hadoop come up with the two beautiful components which are called HDFS and MapReduce. HDFS and MapReduce. What is the second question? Why we need Hadoop? The immediate question from the interview is, why we need Hadoop? Why we need Hadoop? To answer this question, first we need to understand how an existing system is working. What is the problem with the existing system? To answer this question, we need to understand what is the existing system. which is called traditional approach. What is the traditional approach? Then you can find the limitations of the traditional approach. Then we can easily explain them. This is how we need Hadoop. Try to understand traditional approach. Try to understand traditional approach. Traditional approach. Traditional approach. What is a traditional approach? Traditional approach means whatever the approach we are following currently, whatever the approach we are following currently, that approach is called traditional approach. That approach is called traditional approach. How data is getting processed using traditional approach? How the data is getting processed using traditional approach? Very simple, guys. Here, if you want, you can draw the diagram. So instead of I don't want to waste the time to by drawing the diagram. Anyway, I have the slides, so let me show you the slide. Okay, let me draw a diagram, so that may give you better idea. So in a traditional approach, what we will be doing, we will be getting the data. We will be getting the data from the different sources. We will be getting the data from different sources. What are the sources? It can be your financial institute, it can be your social media, it can be your sensors, it can be your satellite, it can be your CRM or ERP applications, it can be anything. From here we will be getting the data. We will be getting the data. This is raw data, guys. What are the data we are getting from the source, we'll call as a raw data. So why we are calling raw data? Very simple. The data which is coming from the source directly to, which is the source is directly emitting the data, which is not gone through any process. That's why that data will call as a raw data. So the raw data may contain the duplicate records. The raw data may contain hexadecimal, different format of the data. So that data has to process. So to process the data, we are using ETL. In existing system, to process the data, we are using ETL. We are using ETL. What is the ETL? Extract, transformations, apply some transformations, and load the data. And load the data into a system where we can store the data in the form of tables. In the form of tables, we can say it is a database or data warehouse system. So before loading the data into this, we'll apply the normalization. Will apply the normalization. So whatever the data is getting from here, the raw data will be processed here using your Informatica ETL tools. I'm talking about Informatica, Talent, Ab Initio, MSBI, whatever the tools you are available, ETL tools are available. Using those tools, which are licensed tools, guys, which are not open source. Using those tools, we'll be processing the data and we'll be loading into our database system. From here, we'll be connecting to our reporting system. We'll be connecting to our reporting system. From here, we'll be generating the reports. From here, we will be generating the reports. So these reports will be using by, it can be chart report, it can be bar chart, pie chart, or whatever the chart it is. These reports will be using by your business analysts, business users, or who will take the business decisions, so like a data warehouse administrations, whoever it is, who take the decisions for the business, right? So this looks good only. No, why we need Hadoop? This looks good only. Why we need good Hadoop? So this approach is really good when you have a less amount of the data. This approach is really good when you have a less amount of the data. But we are staying in the world where we have a huge amount of the data. Where we have a huge amount of the data. This approach has been designed decades before. This approach has been designed decades before. Those days, the data was very less. Those days the data was very less. That time this is very well suitable. This is what this is suits very well. Those days this application, or you can say this approach, this system was well suited because those days they were having a less amount of the data. They were having a less amount of the data. So very okay, fine. So why we need Hadoop then? Now the data is increased huge. The data is become huge. So as soon as the data become huge, As soon as the data became huge, it started giving some problems. What are the problems? Let's see here. So I'm getting the data, processing the data, loaded the data into database or data warehouse system, then I connect it to my reporting system, or whatever you call your processing system. Your processing system, you can call your processing system. Here, as soon as I selected a report, I want to see last 6 months. Let's take an example of Amazon data. In Amazon data, I want to see my sales from last 6 months. How many new registrations? How many mobiles has been sold out? What is the sales of home appliance? What is the sales of the books? I want to understand. Then they have started querying from here. So when they started querying from here, the data is there other system, other cluster, or other rack, or whatever you call, other data warehouse system. The data has to travel towards your processing system. The data has to travel towards your processing system, where the traveling itself, the moving data from one disk to another disk itself is taking so much of time. So first limitation is, the very first limitation is cost is involved, because you have to buy here. It is the ETL tools are not open source, you need to buy. So the data warehouse system, you need dedicated hardware here, dedicated hardware, so cost is involved. The second one is, you are moving the data, processing time, the huge time it is taking. So third limitation is, the data is not distributed. Data is not distributed. Data is not distributed. And so because of data is not distributed, data is not processing parallelly. Data is not processing parallelly. And when I'm processing this data, if this machine is gone down, I do not have automatic backup. I do not have a automatic backup. I do not have a fault tolerant. I do not have a data localization. There are so many limitations we saw as soon as the data is grown, right? So as soon as the data is grown, we started seeing so many limitations. One is the cost, data is not distributed, no parallel process, no parallel process. The fifth one is, there is no data localization, there is no data localization, there is no fault tolerant, there is no fault tolerant, there is no automatic duplication. Auto duplication is not there. So these are the limitations of the traditional approach. So to overcome these limitations, we need Hadoop. The answer to second question is, so the traditional approach is giving limitations like a cost is involved, a time consuming process, data is not distributed, there is no parallel processing, there is no data localization, there is no fault tolerant, there is no automatic duplication. So because of these reasons, we need Hadoop. We need Hadoop. We need Hadoop. So how Hadoop solve these issues, we will see in a next question. We will see in a next question. Okay. So these are the problems. So why we need Hadoop? It answers. Why we need Hadoop? It answers. Answers from the, first you need to understand what is the traditional approach, how it is working. So what is the problem with existing system? Cost, time, right? Cost, time, auto scalability is not there, and data localization is not there, fault tolerance is not there, right? Automatic duplication is not there. Because of that, no, we are facing the problem. The answer to question 3 is, so those are the limitations what we have seen. The next question is, what is big data? Next question is, what is big data? The third question is, what is big data? So we'll be keep hearing this question. Big data. The big data is a huge amount of the data. Very straight answer, guys. Big data is huge amount of the data which you cannot able to store and process using traditional approach. Big data is huge amount of the data, huge amount of the data, huge amount of the data which you cannot able to store and process, store, manage and process using traditional approach, efficient manner, that data is called big data. What is a big data, guys? The huge amount of the data which cannot able to store, manage and process using traditional approach in a given point of time or efficiently, that data is called a big data. So sir, how huge amount of the data, how much huge, sir? How much huge? How much huge? There is no limit for that. There is no limit for that. So we can say big data, even 1 GB is a big data, 100 MB also big data, 1 TB also big data, 1 petabyte also big data. You can say there is no specific measurement for the big data. Big data means a huge amount of the data which is not able to process and using current system. It can be because of the size, it can be because of the structure, unstructured, semi-structure, whatever it is, that data we will call as a big data. So how can you say 100 MB is a big data? How can you say 1 GB is a big data? Because I'm able to process 100 MB data, because I'm able to process 1 GB data using traditional approach. Yes, you are able to process 1 GB or 100 MB using RDBMS. So what system you are using here? What system you are using? RDBMS. But can I send attachment as an attachment via mail, via email? Can I send 100 MB as an email, 100 MB as an attachment through email? I cannot send. For email application, 100 MB is a big data. 100 MB is a big data. Can I send 5 GB or 10 GB or 1 GB to a Bluetooth? I cannot send. It's a limitation for that. So when you say big data, when you're answering to the big data, and what context we're using that data, what context you are talking about? You are talking about RDBMS, maybe 1 petabytes is a big data or 1 terabytes is a big data for it. When you're talking about email application, 100 MB also big data. Okay, so the answer for what is big data is the huge amount of the data which cannot able to store, which cannot able to manage, which cannot able to process efficiently using current system or traditional approach. That data is called big data. The data can be 100 MB, it can be 1 GB, it can be 1 TB, it can be 1 PB or whatever it is, whatever the data it is. So that is a big data. Coming to fifth question, classification of the big data. So very simple, guys. So people may not ask you what is the classification of the data directly. They'll be asking what is the structured data. What is the structured data? What is the, they may ask you what is the classification of the big data? Big data. So you can say that structure, and you can say unstructured, you can say semi-structured. There are three classification based on the, so how they have divided into three categories based on the data format or the data appears, the data follows the what type of schema it is following. Based on the schema, based on the pattern, based on the data appears or format of the data, it has been classified into three categories. Some people say it only two categories, some people say three categories. So you stick to what you are going to explain. So if you are going to explain three categories, stick to three categories. So what is a structured data? Sir, when I look at the whole data, it has a proper structure. When I look at the whole data, it has a proper structure. The data has been properly divided with a single delimiter. With a single delimiter. Wherever I compare this type of data, which will follow the same schema or same pattern. Let's take an example, tables. You take MySQL table, you take Oracle table, you take Postgres table, you take DB Derby table, whatever the table, it is a table in the proper structure. The delimiters are columns. The delimiters are columns. So the best example for structured data is tables. And the second best example for uh, structured data is Excel sheets. Your Excel sheets. The third best example for structured data is CSV file, comma separated file. What is the comma separated file, sir? So what is the comma separated file, sir? So if you look at here, my data, this is my data. My data is properly divided by comma. If you see my data here, my data is properly divided by comma. This is CSV file. So there is something called tab separated files. So when you look at the tab separated, very simple, let me show you here only. So let me take one row from here and show you what is the tab separated. So whenever you look at the data, it is properly separated with the tab. The data is properly separated with the tab. Whole data, the whole data, not part of the data, guys. The whole data followed proper structure. The whole data followed proper structure. /t, enter the data. If you have 100 rows like this, all follow the same structure. So you can have a hash separated, like a comma separated, you can have a hash separated files, you can have a tab separated files. The best example for the structured data is tables, the data which is properly formatted, or the data is following single schema, or the data is following single delimiter. That data we can call as a structured data. You take any type of data, you take a CSV file, let's take example of CSV file. You take Microsoft CSV file, same comma separated. You take open office CSV file, same format. Okay, or you take table, you take MySQL table, same format. You take Oracle table, same format. You take something else table, the same format, right? You take Excel sheets, you take Microsoft Excel sheets, and you take open office Excel sheet, or you take MacBook has one office system, you take that operating system, that file. So all follows the same structure. They all follows same structure. The best example for the structured data is table, XLS, CSV, TSV, and tab separated, whatever hash separated. Coming to unstructured. So unstructured is very simple, sir. Unstructured means which never follow any structure. The data is like the best examples. I'm giving you best examples. Unstructured is images, audio, and video, and coming to semi-structure. So guys, the most of the world or most of the world is processing a semi-structure. 80% of the data is semi-structure, not the unstructured. I mean, that's what I'm saying. Most of the data is in semi-structure. What is a semi-structure? So when I look at the whole data, I'm not able to find a structure. But when I go little deeper, I'm able to find a small, delimiter. What is that? Let's take your emails. Let's take an email. Let's take before the text file. Let's take a text file. So when I look at my text file, let's say let me take some text file here. Let me take my some text file here itself. Yeah, this is my text file. Okay, this is my text file. So which I have written this text file. This is my text file. So when I look at this text file, or when I'm taking another text file here somewhere, so I'm taking another text file here. This is another text file. So is the both are same? No. But when I look into line wise, this has the line. Oh, this file also has a line. Okay, very good. And when you look into inside the line, each word is separated with a single space. Each word is separated with a single space. Here also each word is separated with a single space. Okay, when I go little down, I'm able to find this text file has a single delimiter, right? So when I look at the high level, I'm not able to find any structure, but when I go little down, I'm able to find the structure. That kind of data we can call it a semi-structure. And the next is your emails also text files. Your log files. So what is the log files? Log files are, you can say it's a semi-structure. How can I say log files are semi-structure? Sir, I'm getting the data in proper structure. No, log files I'm seeing IP address is coming, date is coming, and which operation I have done, what type of log it is. I'm getting proper session ID, and so all this properly coming, sir. That is a successful log. When you look at the failure log, the data will be zigzag. Okay, that's why log files also semi-structured. So your XML files, your JSON files, right? Your log files, XML files, JSON files, this all comes under semi-structure. So the answer to fifth question is The answer to fifth question is the classification of the data. There are four classification has been made. Three classification has been made. First one is structured, second one is the unstructured, third one is the semi-structured. And what is the characteristics of the big data? So next question is, what is the characteristics of big data? The characteristics of the big data is, people will be keep hearing that they may not ask you that what is the characteristics of the big data. They may ask you that what is the 3V problem. What is 3V? So what is the 3V problem in big data? They'll be saying that, they'll be asking, I'm seeing some 3V problem in traditional approach. What is that? What is 3V? Guys, it is not actually 3V, it is a 6 V's. It is not 3V, it is 6 V's. I will explain what are they. You can say them. These are not 3 V's, sir, it is a 6 V's. So I have seen some books on here, sir. I'm sensing it is 6 V's. What is that? The first V represents volume. So it's saying that how much amount of the data I'm going to process, how much amount of the data is getting produced. Today I'm getting 1 GB, sir. Tomorrow it may be 2 GB. Tomorrow, day after tomorrow, it may be 10 GB. Right? So that is the first V represents. That is the first V represents how much volume of the data. So there is second V is velocity. Second V is velocity. So let me take you through the slide, guys. That will help you to understand easily. So that'll make you understand easily. We all be discussing these things, not a problem, or question wise. So not to worry about it. Yeah. Volume, velocity, variety, veracity, value. There is something is missing here. Variability. There are 6 V's. All 6 V's are volume, how much amount of the data I'm going to handle, and next V is velocity, how fast the data is getting generated. How fast? Sir, you are giving me 1 GB today. So to generate 1 GB data, how much time it is taken? Your Facebook is giving you 100 TB per day. So to generate 100 TB, it's taking 1 day. Your YouTube channel is every second new freshly 1 hour video is getting uploaded. So how much data it is giving? So the velocity says that how fast the data is getting generated. The third V says that variety. We just discussed about variety. 3 different type of data: structured, semi-structured, unstructured. That's a different type of data it is. The fourth V is veracity. Veracity. How good the data is. How accurate the data is. How trustworthy the data is. How trustworthy the data is. What are the data I'm getting? Is it accurate data? Is it good data? Is it so that type of data also you are able to process using Hadoop. And there is one more V called variability. What is variability? So variability is keep changing. It looks similar to your third V, but it's not actually similar to third V. So variable. Today I'm getting structured data. Tomorrow it may be semi-structured. Day after tomorrow it may be unstructured. So the data is changing. Variable. Keep changing the data. That data is called variability. That V is represents variability. There is another most important V is there. That is my favorite V. It is value. We should have some value. Why we are learning Hadoop? It will give some value. It will give some value. So why you are processing huge amount of data? To get some value out of it. To get some value out of it. Right? So that's answer your question. Challenges, we just seen what are the challenges we face with the big data. The challenges are like it is expensive. It is the challenges. What are the challenges we associate with our big data? The first challenge is cost effective. It's a cost. Time consuming process. Upgrade. Suppose if you want to upgrade, it is not that much easy to upgrade. There is no data locality. and there is no fault tolerant. These are the major problems with the big data. Okay, and so next question is, what is data locality? So we'll be keep hearing that data locality, we'll be keep hearing this. So to make you understand data locality, I would like to take you I would like to take you through I would like to take you through a small slide. Okay, or let me explain. Okay, let me take you through small slide. Let's assume that, before getting into a slide, let's assume that you are a owner of a hotel in Bangalore. You have a very good hotel and you are providing very nice service. You are providing very nice service and you are providing very nice food or breakfast, whatever you call, right? So everyone is happy with the service. Then your hotel become famous. So initially it was only 2 floors, and initially it was only 2 floors. Let me draw here. I'm talking about data locality. Data locality. To explain the data locality, I'm taking a simple example. A data locality or scalability help you to understand that. Let's assume that you have a hotel. You have a hotel which is 2 floor hotel. Let's assume that you have a hotel which is 2 floor hotel. As of now, you have a 2 floor hotel here. Okay, it's a hotel, and you are providing very good service. And here, this is your breakfast area. This is your dining area or breakfast area. So this is your lift. Okay, and the people have started coming here, and your hotel, you are providing very good service. Everyone is really happy with it. Then it become a famous. Then what you will do immediately? No, I want to improve my whole business. So you have gone and you have improved your business. I mean, you have increased your hotel size, 2 more floors or 3 more floors. You have invested so good amount of money here. You have invested good amount of money here. So for the constructing or for the no lift and all, we need a lift also, right? So we have invested good amount of money. Still, you're providing very good service. People are coming here, they're having their breakfast every day morning, and you are providing good service. And all of a sudden, I mean, not all of a sudden, your hotel became world famous. Your whole hotel became world famous. Then what you decided? No, this time I want to take advantage of this. Let's make it double the size of the hotel. Make double the size of the hotel. So when you made your hotel size is double, the next day you started facing an issue, because the hotel is very big hotel now. The people are coming, so many people are coming, the hotel is full. The immediate next day you started facing the problem. What is the problem? Because your dining area here only, every day everyone has to come to dining here in the morning, right, for the breakfast. So everyone will start coming. Your lifts, even though you have a very efficient lift, every efficient elevators, you cannot able to clear the crowd here, and you have only one kitchen here. So they're not, the cooks are not able to provide the food in time. So here, so many, some people are stuck at here, they're waiting for the lift. Some people are stuck at here. Even your lifts are not able to clear your crowd, right? This is an SQL model. This is an SQL model. How it is related to SQL model? So let's go ahead and see the slide which I'm going to show you. Yeah, so this is your initially your hotel, SQL hotel. So as whatever the story I have explained, this is what you have done. You made it double the size of the hotel. So then what happened? All of a sudden we started facing the problem. So the people are started coming to hotel. So hotel is full now. So they started piling up at the lift as well as in the breakfast area, as well as at the breakfast area. So then if you take your hotel as a data storage in RDBMS, if you take your elevators as the network, and if you take the people as the data, if you take your dining area is nothing but a data processing, it is it is relatively representing it is relatively representing the traditional approach. We have a data storage in one place and we have a data processing in another place. We have a very good bandwidth in between, a network in between. So now even though you have a very high bandwidth, even though you have very high bandwidth, your your process engine is not able to clear the crowd. Even though you have a 10 GB per second bandwidth is there, but you are getting a huge amount of data, TBs of data, your process engine is not able to process that much amount of the data, and it's not able to give. There you started facing a problem. So how this problem is solved? So this problem can be solved using Hadoop. So what Hadoop says that don't have a hotel it in the one place. Sorry, don't have your breakfast area in this one place. Have your breakfast area in each floor. Have your breakfast area or have your dining area in each floor. So whoever wants the breakfast, they can have a breakfast in the respective floor only. They no need to travel. They no need to use the elevators, right? They can get processed or they can get have a food at their respective floor only. So what we need to do every day morning, we need to tell to our chef, you take your ingredients, you take your recipe, go to the floor 1, go to floor 10, other guy X will go to floor 1, Y will go to floor 2, Z will go to floor 3, and so on. So they will prepare the breakfast in the respective floor only. Then they will get processed there only. It means what is happening here, the data is getting processed wherever the data is reside. The data is getting processed wherever the data is resides, right? So now you can go ahead and improve increase your hotel double triple, no problem at all, because how many you can store a huge amount of the data with respect to when it comes to data. You can fill your hotel with all the people, still you don't have any problem. Still you don't have any problem because the data or the people are getting their breakfast at the respective floor only. They're getting their respective food at the respective floor only. So they're really happy for it. So you don't need to know degrade your service, like you are getting famous, right? So how it is happening? It is happening data locality. What is data locality? Wherever the data is there, wherever the data is there, you process in that respective location only. Don't move your data towards your process engine. The moving data from one disk to another disk is the costliest operation, where we will start facing so many problems. Don't move your data, keep your data there only. Send your logic to process. Send your logic to process. Your logic has to go to respect to data and it has to get processed there itself. So that will give you a better performance. That is called data locality. So let me take a real-time example for that. So let's say on a weekend, in a weekend, so let's take a real-time example. Let's say in a weekend, I thought to get some groceries to my home. So then what I will do, I'll wake up in the morning, then I will go to the store. I will go to the store in the morning. I'll spend 1 hour to choose my items. Then I'll come back to the billing counter. The billing counter I have to wait for 1 more hour or another 10-15 minutes there. Then I have to come back in the traffic to home. So I have to spend almost of 1 hour to 2 hours of time I need to spend there. Instead of that, I'll be sit at my home. I'll be taking my classes. I'll be going through my whatever it is. I'm watching my favorite channel. I'll be watching my cricket. So what I will be doing, I'll just pick up a phone and give a call to the store saying that I need this, and they will get delivered to you. What is it called? Customer local. Wherever the customer is there, the service is coming to the customer. So in the same manner, wherever the data is there, you are processing there only. That is called data locality. That is called data locality. I hope you guys are clear about the data locality. Let's move to next question. Fault tolerant. What is fault tolerant? Very simple, guys. Fault tolerant means fault tolerant means I have one source is here. I'm started fetching some data from here. I'm started fetching the data here. When I request the data, while sending the data, this mission is failed. My request will get failed. My request will get failed, right? Instead of that, there is some guy who will tell me, okay, that is failed. Don't worry. You go to here and get the data. You go and get the data from other place. The same data is available. You go and get the data from other place. That is called fault tolerant. Fault tolerant. What is a fault tolerant here? It means you went to get some data from one location, you went to process some data from one location, that machine is gone out of network due to some problem. Your job should not fail. Your job should not fail. Your job should redirect to some other place where it has the same copy of data. Where it has same copy of the data. That is called fault tolerant. A simple example. Let's say you went to get let's say you were absent to one class. Then you decided to go and get from your book from your friend. You went to your friend home. So when you went to your friend home, your friend is not there. Then his mom told you, no, he's not there. He's in some other friend. So then you, instead of coming back, you'll go to other friend room to get a book, because he has attended, he also have the same notes you can get from him. That is called automatic fault tolerant. If one source is failed, we can get the response from other source. We can get the response from other source. That is called automatic fault tolerant. In a traditional approach, that mechanism is not there. In traditional approach, that mechanism is not there. Okay. The last question is, what are the distributions are available with the Hadoop? What are the distributions are available with the Hadoop? Guys, there are so many distributions are available with the Hadoop. I'll be listing out here which are the little famous one. Okay, so the one is Apache Hadoop. Apache Hadoop. So this is a frequent asking interview question. They want to check whether real time or not. The first question they will ask you that, what is the distribution you are using? You should know what is the distributions, which Hadoop you are using. There are so many type of Hadoops, but the concept, the coding, everything is similar. Everything is similar, but different companies are maintaining different Hadoop. Why? Because Hadoop is a open source, so different companies, contributors are interested, and they have taken the source code and they have implemented their own customized flavor for it. They have added more flavor for it. The first one is Apache Hadoop, which is a open source. The second famous one is Cloudera. The third one is Hortonworks. Hortonworks. The fourth one is AWS. Map are also there, but AWS, and instead of AWS, I can say EMR. Okay, and other one is Mapr. There is something called Mapr distribution, and other one is called Azure. Microsoft is coming into picture, and there is something called there are some other also. Intel has Intel has their own uh, Intel has their own Hadoop. They call this, I think, Pivot. There is something called Greenplum. There is some, so Azure is HD Insights, guys. Azure call it's a HD Insights. Okay, these are the some famous, that these are the some famous distributions, Hadoop distributions. So based on our your knowledge, based on your project, based on your on what you have practiced and what you have learned the course, you can specify that which distribution you are using, which distribution you are using for your project. So the first question from the interviewer, suppose if you get a doubt, you are not real time, he will ask the same immediately question is, which distribution you are using for your Hadoop. And second question, what is your cluster size? What is your cluster size? So for the cluster size question, we will be discussing in the next video. Okay, it's very simple to answer. I'll tell you that. Thank you guys. Thanks for your time, and happy learning.